Okay, well, let's see. We're about 12 minutes in. That was a good way to kick it off, really. So, everybody, we welcome back. Welcome to our second meeting year of the year, I think. Are we there? I think so. But we've got Eric in the house, and Eric was kind enough. I said, hey, it's a last minute thing, but you've got this new tool, which I saw a little bit of it the other day in the X Teams, I think, and I thought you guys would really like to see it. So Eric has been working like a machine, as he always does, and he has made amazing progress on his client side tool, his client code generation tool. So I'm excited to see it. Eric, are you ready to go? You're there. All right. So
I'm here.
You're here.
So yeah, been busy weeks, very busy weeks. Don't know where you guys caught up the last time. It must have been 2 weeks ago. So that was probably when I was still in the middle of getting the client code generator working, especially on the TypeScript side. I can happily report that it's being used in at least 2 projects already on the TypeScript side. That was an interesting exercise. I didn't have a development environment for TypeScript, so I just wrote the code the way I thought it was okay, and the development environment would tell me that there were no syntax errors and such, and that it seemed like it would link, and then I would just throw it over the wall to one of the teams that was waiting for it, and then they started testing and debugging and pushing fixes. So it was a real cooperation with some community members. Really fun to do. We had several sessions together where it was like ping-ponging constantly. They would find the bug. I would immediately think, oh, right, yes, that's something I forgot, and then quickly fix it and then throw it over the wall again. And they would test it again. So they are now running some kind of a poker application that runs in a web environment, runs the client-side TypeScript code that interacts with the smart contract they created. And it runs through the web API. So the WASP node has a web API that can be used to access or interact with smart contracts. And what I wrote was some code that basically interacts with that and generates a type safe layer on top of the service that connects to that to the smart contracts on a WASP cluster, and then the user doesn't have to implement his own entire communication with the WASP node, etc. But you can simply start using it. It's a matter of a few simple configurations, and it will run. So that was fun. I've actually seen the poker already in action a bit, and starting to look good. So it's going to be interesting when they get to the point where they come out with that stuff.
Yeah, it's kind of funny. There's been poker being talked about for years. Finally, it's somebody's actually done it. That's awesome.
Yeah, and it looks quite good on the web as well. They have a nice table with seats, and cards will show and things like that. So yeah, it's fun. I haven't done much with it yet because, of course, right after that I got shanghaied into helping with the refactoring, because the refactoring progress for Stardust is such that the first basic VM can run in the solo environment. So I'm currently in high tempo doing a lot of refactoring on the WASM VM, so that I can push that towards the branch that they're working on, and then they can write tests for the smart contracts. So
Hey,
that's
Eric.
yeah.
Eric, just as a quick refresher, a lot of this isn't the X team, so this is the Americas group. So,
Right. So Stardust, what is it?
So I was yes. What is Stardust and what is Solo for them? Yeah.
Okay, Stardust is essentially our code name for the effort that we're doing to get the smart contract protocol running on the Chrysalis nodes. So a while ago, we came out with a tokenization framework that we published, and that showed the plans for moving forward on how we were going to deal on level 1, so on the Tangle itself, with tokenization, which means that we can create our own tokens on the Tangle, new tokens. So it's no longer the colored tokens that we had, but it's actually you have what we call a foundry, and the foundry can be used to generate tokens and such. So the foundry has all the data of the limitations of the token. So you could create, for example, a wrapped Ethereum token on the Tangle, and it's literally a new token that is being generated in addition to the IOTA token, and it runs on the same Tangle. So that's an interesting development. One thing we're using foundries for is to create NFTs as well. It's kind of a similar thing, only there's a limited supply, of course, with NFTs. And these foundries are going to be controlled by smart contracts, and they are also implementing some other stuff that we need. Like, for example, in that tokenization framework, we have alias addresses. That means you have a fixed address and you can rotate the owner of the address. That means you have another address with a private key that controls the alias address. And that's a feature we needed for the smart contracts, to be able to rotate the committee without constantly changing the address associated with the committee. So the smart contract will live on the same alias address, and all the requests for the smart contract will be sent there. The anchoring will take place on that address, and the committee who needs to set up a so-called BLS address. It's a threshold address where N out of M people need to sign to be able to actually transfer tokens, which is the system that we use to get consensus within the smart contract committee. So those alias addresses are very important to us, because now we have the ability to rotate out committee members and rotate in new committee members. We would simply generate a new BLS address and then make that the owner of the alias address, and then that will be controlled by the committee as usual. So these are some serious deep new functionalities for the Tangle. And maybe you remember right before Christmas, there was also the announcement of the Shimmer Network, the
Yep.
staging network, which is going to be essentially a copy of the current Chrysalis network. And that is where the node software will be adjusted. So it provides the tokenization framework, and where we will build our first version of the smart contract system that talks to that system instead of the current Go Shimmer node. A bit of an awkward naming happening there. Go Shimmer and Shimmer are two completely different things. They are literally are not able to work together, and the refactoring that we are currently doing towards Chrysalis, which will be running on the Shimmer network, is completely different. So the interaction with the nodes, etc., we are no longer interacting with the Go Shimmer node, but we're now going to be interacting with the Bee and Hornet nodes. So the Bee and Hornet teams are hard at work on implementing the tokenization framework, and we are constant communication with them, and in the meantime refactoring the lower levels of the smart contract protocol so that it will talk to those nodes instead of the Go Shimmer node, and so that it will work on the Shimmer network. And then once we have been able to test it long enough, that's when we will have a transition to the main network. So that's going to be quite a bit in the future still, I think. We want to be able to test it properly and have it properly audited and everything. And those things simply take time. Essentially, especially nowadays, because pretty much everyone wants auditors. So auditors are in short supply usually. So you have to plan way ahead. And yeah, the things we're doing are again on the bleeding edge. So we need to first get our assets straight before we can even ask somebody to audit it for us.
Yeah.
So that's in a nutshell.
Yeah, and then so that was a great explanation, and I think I learned a little bit about aliases. I just knew a little bit about it, but that was a great explanation. And so then you're going to
the Stardust project is essentially the project that will convert the smart contract protocol so that it actually runs on the Shimmer network.
Gotcha.
On the staging network.
Okay, and then
that's where I got shanghaied into to make sure that that the WASM VM will be transferred to that system and gets to a working condition.
Okay, and then before you go into the client, just a brief description of Solo, right? Because I think that'd be important for a refresher for the folks.
Right. So the way it has been set up is that we have a support for developers built into the WASP node to make sure that you don't constantly have to run your own cluster of nodes and load your smart contract in that and send transactions to that, which all takes a long time and a lot of overhead, especially if you want to do if you want to run unit tests or if you want to do development and testing. You want a way more deterministic system to be able to do that. So what Ivaldas did about a year ago is he created what we call the Solo tool, and that is essentially an environment that has the WASP code built in, but it simulates talking to Go Shimmer, and it simulates the consensus. So it does essentially everything but as if it runs on a single node, and it, like I said, the whole accounting of the tokens happens in a simulated environment. But otherwise, you run the exact same code that runs on the nodes. And to us, that's very helpful because that means we can do all kinds of testing. We can even test results from a request, because what we're doing is we're synchronizing everything. So that means that asynchronous requests that are normally being thrown over the wall and then at some point will be run by the nodes are now in the Solo environment are immediately executed synchronously, and therefore you can wait for the results of it, and you can test whether the results are what you expected. So otherwise you would send it over the wall, and then your program could already get data from the smart contract, but it could be that the request wasn't processed yet, and then the data you get is off. Right? That's the problem with an asynchronous network. And so by synchronizing all that, we have now a development environment where it's very easy to set up tests and debugging.
Very big number, but it's a number that not only talk about market share.
I think somebody needs to mute.
Yeah, somebody needs to mute, please.
So anyway,
I didn't.
What now off my rocks? What was I talking about? Oh yeah, the Solo environment.
Yeah,
so
Solo.
So for us, it's very important to first have the Solo environment running again in the Stardust project, because that is basically where we do all our testing. And that also means that we do not need the connection to the node software yet, and still are able to do our testing, right? So while the Bee and Hornet teams are implementing their stuff, we have pretty much created a simulated Bee and Hornet interface. And behind that is a very simple, dumb database that simply keeps track of the UTXOs that went out and that are there. And it acts as if it's a Tangle, but it doesn't need any consensus or anything because it's in a single threaded environment. There's nobody else doing stuff in between normally. Although there are certain features that we can actually do multi-threading in the Solo environment, but that makes testing a lot harder. So we usually avoid that. So anyway, yeah, that's the Solo environment. And what I've been building in the last few months is with the Schema tool is the code generation of the smart contract code, which gives you a type safe interface to your smart contracts with an easy way of calling things, with an easy way of processing things, generating a lot of boilerplate code so that you don't have to write the code yourself, and so that you're also absolutely sure that the code works because it's been tested properly, and it's something that the generator, which has been tested, will regenerate for you. So you can define the layout of your smart contract in the schema, and then the Schema tool will generate the code for you. And maybe I will share my screen now.
All right.
That might be a good idea. Screens. Go live. Okay. Is that visible? Oh, you will have to switch to my live.
Yeah, I have to switch to yours. Yeah, you guys we just switch on live for his. I got it. I can definitely see it.
Okay, thanks, Dave. Now everybody should be able to see it. So what you're seeing here is some test code that tests the client code. So the thing I've done after generating that smart contract code was take the next obvious step, which is generating the interface from external to the smart contract that works through the web API in a similar fashion. And of course, we're using the Solo tool to test that in our Go environment. Let me first give you an example of what the schema file looks like. So this is a schema file. It's essentially a standard file. It's called YAML, Y-A-M-L. It's similar to JSON, only much more readable, with less punctuation and quotes and whatever. And what you can do in this schema file is you can define collections of key values, key value combinations. And I use that to define the smart contract. So what you see here is that the name of the smart contract is test wasmlib. The description is an exercise, several aspects of wasmlib. Wasmlib is a library that I created. You can have events. I have a test event, and that test event has a name and an address. The name is a string parameter, and the address is an address parameter. Currently don't have any structures. I disabled that for now. Type defs are ways of creating more complex types by name so that you can easily use them in other places. You can define the state variables that you're using in the contract. I have, for example, a bunch of arrays. Those arrays are defined as a map where the key is a string and the value is a string array. So I have a bunch of string arrays and I can index those by a string key. And the string array itself is an array of string. So I'll show in a minute what that looks like. I also have maps that map a string to a string map, where a string map is a map that maps a string to a string. So this is why you want to be able to have the complex definition split out as type defs, because otherwise you quickly get lost in the level of it's a map of string of map of string of string, right? You quickly start going cuckoo when you try to keep track of that. And I also have a random variable, which is an integer of 64 bits long or 8 bytes long. And then I define a number of functions, and because there's arrays in here, I'm testing the array functionality of the smart contract system. And there's a function to clear an array with a certain name, to create an array with a certain name, to set the name of the array at index X, the index, and we set the value. We have a map that we can clear and that has a name. We have a map that we can create and that has a name. We have a map where we can set for that name. At the key, you can put a value, and then there's some other functions there that do all kinds of more complex things that go too deep to explain right now. You can also define views. Those are functions that are not running through the Tangle as a request, but are directly asking for the data from the node, and without having to go through the Tangle. So you can inspect your state if you have a user interface in the web. That is how you will retrieve data from the smart contract, usually by calling a view. So for example, I want the length of the array with that name, and that result it will be the length, which is an integer 32-bit. The value at index this of array named name is the result value is this value, which is a string that will be returned, etc. And so we do all kinds of things like that. Here I have for map, get the value. I test the randomizer, so I get the random variable, which is from the state. And this is essentially the definition of my smart contract. And so what I do when I want to generate code for this, I run the schema tool with certain parameters. I do it now in my development environment because that makes it quick and easy. So I simply run it with a number of parameters. And if I go to the run window, let me first show what parameters I run it with. I tell it to create Go code, to create Rust code, to create TypeScript code. I tell it to force the generation because it will normally only generate files when the schema file or the schema tool is newer. Otherwise, it's not necessary to generate new files. And minus client that means that I also generate the client code, which is separate from smart contract code. So if we go again to the run screen, then you see that it says generating Go code, generating Go client code, generating Rust code, generating TypeScript code, and generating TypeScript client code. So we don't have Rust client code yet. That's for the future, but I can only do so much. So right now I'm working on refactoring. So this has been run, and I demoed the client code in the past. I will just quickly show. Here is the test wasmlib Go code, and it has generated these files minus this one. This one is the only one that I, as a user, modify. All the other files, and they explicitly have a disclaimer that it's been regenerated by the schema tool. Do not change this file. Because every time you change something to the schema or you run the schema tool and it generates files, this file will be overwritten with the latest state that matches exactly the schema definition file. So what you normally do is you modify the schema definition file if you want your interface to change to your smart contract, and then you get a bunch of constants that it automatically defines. It defines a contract interface, which is a whole lot of structures and calls that can be used. It defines the event structures that are there and their parameters. It defines a bunch of keys, although in the future a lot of that is going to go away. That's part of my refactoring. There's a lot of, I call it CRUD, that has been grown over time because of all kinds of fixes and changes, etc. And I'm currently taking the opportunity to straighten out some stuff. And I'm probably going to end up with less code than we had before the refactoring. This is the file where the smart contract will tell the system what functions there are and how to call them. And then each function will automatically do some stuff, like, for example, if a parameter is required, it will do a test before calling the actual function. It will do a test whether that parameter is actually present. If not, it will generate an error, and you can see that there's a missing mandatory name parameter here. That means that you don't have to do that all by yourself, constantly having to add. It turned out when we first created smart contracts that most of the code, or maybe half of the code of a smart contract function, consisted of checks on the parameters. And so there was a lot of repetition there, and I factored out most of that repetition and moved that to the code generator so you don't have to deal with that. You can simply indicate whether it's an optional or mandatory parameter, or you can indicate who is allowed to execute the function and things like that. And then the code generator will automatically generate the code that checks those prerequisites for the function call, and only if they all pass, it will start the function. It will also automatically log which function is going to be run, and when it's done, it will tell that it has run okay. If this message is missing, it means that something went wrong and there should be an error in the log file instead. So, as you can see, there's a shitload of code that's being generated. Then we have the parameters. Each parameter has been defined and they are retrieved through a number of functions. That means that you get typed variables back. So it knows that the parameter key in this instance, for example, is the string key, and it uses that to retrieve the parameter from the map. But instead of having to do that, you simply call the key function, and that will give you a string back that you can use in your code. Same thing for results. You can set results, and they are type safe and checked. State interface, so this is the interface to all the definitions in the state that I showed in the schema file. The structures that are being generated. These are the actual functions that I manually had to add. So whenever I add a function, I get these two lines, this one, and everything in between is not there. So if I add a new function, it will get added to here, but it will be an empty function, and I still need to fill in those blanks. And that's what I've done here. And what it does here is all kinds of things interacting with a map or interacting with an array, creating an array, setting an array variable, etc. And you can see here, for example, if I want to set a certain array, I first want the name of the array. So I ask the parameters to give me the name value. Then I find the array by asking the state for the arrays variable with the string array with that name. Then I get the index from the parameters, the index value, and I get the value, the string value that I want to set at that index. And then I tell the array to get a proxy to that index. A proxy is kind of a reference to the data because the WASM code executes in a separate sandboxed environment. It cannot directly access data on the node. And so that happens, the access happens through a proxy. And what we do here is we tell the proxy to get reference to that value in the database on the node, and then at some point it will tell that the value needs to be set to this value, and that is when the data effectively crosses the boundaries between those systems. So a very simple show of how we use that. For example, here I have the clear array function. So the setup test function takes care of asking Solo to set up the environment. And it does that by asking Solo to load the smart contract. And in this case, it is test wasmlib is the smart contract. And then once it has loaded that, it returns a context, which is kind of a structure that we can use to access all the functionality of the smart contract. So here, for example, we ask for a function object, which is the array set function of the smart contract. And then we take that function object and tell it that the parameter name should be bands. We have an array in there of bands, and at index 0, we are going to set the value to simple minds. Then we tell the function to transfer one IOTA and post that to the tangle, or the simulated tangle in this instance. And then we require that no error occurs while that happens. So inside this CTX object, there's an error variable that will be set once an error occurs. So then we do the same thing again. We get the bands array, but this time index 1, and there we post the name dire straits. And then at index 2, we post the name ELO, Electric Light Orchestra. You can see what where I'm a fan of. So now I've created 3 entries in the bands array, and I'm now calling the array length function for the bands array. Call the function. This is a view that's being called, and that gives me back results, and the result is a length. And then I can get the length value. I first check if the length exists. It should have returned a length. If it doesn't exist, then there's something not quite right. And otherwise, the value of that length value, should be equal to 3, because we added 3 bands. Then I set the value at index. Let's see what am I doing here. Yeah, the array value. Oh yeah, right. I'm trying. I'm retrieving the value, array value of the bands array at index 1. I call the function, and then the result value should be equal to, well, number 1 was dire straits, so it should be equal to dire straits. Verify that. Then we clear the bands array. That means we make it completely empty. Then we check the length. The length should now be 0. And then when we try to get the value 0, that should not be able to do. And these calls to the smart contract can be run simply by running in my environment. And then when I look at the run window, there you see the results. And this is all the log file output. You can see, for example, that it did the function array set, and then function array set was okay. View array length, okay. View array value, okay. So you can follow in the log file what has been executed, and then you can make sure that that if something is amiss, you can use the log file to see where things went wrong. So that is in a nutshell on how it works on the smart contract side of things. But the new thing that we generate nowadays is the client code. The client code is currently pretty simple, but there will be more. What it generates is events, which generates an event handler. The event handler is an object where you can pass functions to. So, for example, the name of this contract is test wasmlib. I have an event test. So on test wasmlib test, call this function. So I create the handler, then pass in a function to the on test wasmlib test, and now this handler knows how I want the wasmlib test event to be handled, what I want to do with that. It also generates a service, which is a service object that knows how to connect to the WASP nodes and will then interact with them through the web API. And I can tell this service to register the event handler, and thereby they are connected to each other, and now they know, the service knows that if events show up from the smart contract, they have to be passed to the event handler. You can have multiple event handlers if you want. That can be handy if you have several components in your system, then each component can have its own event handler, and you register them all with the service, and then the service takes care of distributing it to the correct location and everything, and you don't have to do anything about that. If I go to how that looks, so here you can again see some solo interaction happening in the test environment of the Go development environment. What I need to do here is I define a chain ID and a seed. The chain ID is the chain that runs here. I started a simulated cluster of only one node. I can show where that it works. If I use my WASP CLI balance command, it will give me the balance. And if I now go to the, where is it? No, this one. You can see here that it executed through the web API ledger state addresses, the address, unspent outputs, and another function, and these return values have been processed and translated into the output here of what the balance is currently in that address. So if we go to the test, what I do is I copied those from the configuration. So they're hard coded currently in my tests. So just for good measure, I test that the seed and the chain are both valid. Otherwise, it wouldn't be running anyway. Then I create a default service client. That's the service client will actually connect to a node, but it doesn't know anything about smart contracts. It only knows about the connection with the web API. On top of that, you create a service, in this case a test wasmlib service for the test wasmlib smart contract. You pass that client in, you pass the chain ID in, and then it's essentially already running. Then I tell it who I want to sign the requests that I'm running with the smart contract, because you always have to sign from an address, otherwise you cannot send requests. And that is the setup for the tests. So then if I want to do, for example, some tests on the event handler, in this case I set up the client like I did above. Then I create a new event handler, and then that event handler, the new event handler comes from the service. So it is the event handler for that smart contract that the service was for. So I already know which event handler that is. And then I can tell that the test event should handle in this way. It needs to print out the name that is being passed as part of the event. I register this handler with the service, and now it will be automatically handled. Now all I need to do is trigger an event, and it so happens that I have a trigger event function as part of the smart contract. So I can simply get the function object from the service. I tell it, give me the trigger event function, set the name of that function, the name parameter to Lala, set the address parameter to, well, some address from my seed, just for laughs. And then I tell it to post that request and verify that there was no error happening. Then I wait for the request to be processed, and then I do another one. I once again ask for a trigger event object. This time I tell it trala, and I ask it to pass the address number 1 in my seed. So addresses are generated from a seed by taking the seed value and an index. Here I used index 0, here I used index 1. And I do the same thing again, and this has triggered 2 events, one Lala and the address of the seed, and the other Trala and address 1 of the seed. So if I now would run this test, and I go to my window, then there we go. You can see that there was some data coming out. Here is the request logging happening. VM message is a request. It was a request for this chain and for this contract. The event that was generated was the test wasmlib, which is the contract, test, which is the name of the event. This is the timestamp when it was created. This is the address parameter that was remember the trigger event function I passed in Lala and an address. Well, here you can see there's Lala and here's the address. And then the second one, we have another VM message, and we see that there is another address. That's the second address in the seed, and I passed the trala to it. And you can see that it has been processing it because it also was logging name is Lala and name is trala. Right, so that way I could easily test if my system was working or not. And this is essentially allowing us to build programs now, simple standalone programs like, for example, bots or other tools that interact with your smart contract, and they can do all kinds of interesting things by simply hooking into the events, waiting for certain events to happen, and when that event happens, it can do something. One thing we use this, for example, is remember a while ago we put out the Fair Roulette demo program, and people were trying it out. Initially, lots of people were trying it out. It was a lot of fun, and then the fun was pretty much ebbing away. And then every now and then somebody would try it out. They would put in a bet, and then hardly anything would happen, and they would always either win or lose, and there were no other people playing. So we created a little bot that figures out that a new round has started, and then it will randomly send some bets as if other people are there. So it becomes more attractive for somebody to interact with that smart contract, with the demo smart contract, and see what's going on there. So finally, let's see. That is old. Things have changed in the meantime a bit. Oh yeah, so here's the TypeScript. You can see all the same files are being generated that interact with the smart contract that we have here. And we also have a client library in TypeScript that has 2 extra files because of the nature of TypeScript. It needs those, but the same files are there, events, service, and test wasmlib. And we also have the Rust version of the smart contract, but we don't have the client code yet. That's something that will come later. Anyway, all this has been generated from that simple schema file. I can literally go like this. Well, let's delete this. Okay. Boom. And we'll delete these files. Boom, boom. And we'll delete these files. Boom, boom. So now I just deleted most of the code of my smart contracts and shouldn't be able to compile anymore. And all I need to do now is tell the schema tool to regenerate my code. And then it, bloop, there they are in red, the new file.
Beautiful thing right there.
That's how simple and how fast it goes. And so if you want to add stuff, for example, I want to add a get bleep function to the smart contract, and that thing gives a result, which is a test, and that is a string. Okay, now I run my smart contract stuff. Okay, let's go to the smart contract. The test bottom lib. If I go all the way to the bottom, here's my get bleep function. So this is the skeleton function that has been generated. Of course, there's more happening. For example, in lib, it will have the, let's see, where's the get bleep? Bleep. There we are. So it creates a get bleep context structure that has results and that has an interface to the state. The function is generated that logs that this function has started. It sets up the context with the correct stuff in there. Then it calls the function itself, and then finally it tells that the bleep was okay. And then if I go to the bleep where I was before, I can now, for example, have results, name was test, value, set value, bleep. So now I set it up so that the smart contract, whoever calls the get bleep function, will get the test field set to bleep, and it's that simple to add stuff to it. So I could do add a test here that actually checks that. Let's quickly cannibalize another one. Test bleep. Then we call the bleep get bleep function. Get bleep. There it is. We don't need to transfer IOTA because we're doing call. No error. Okay. Boom, 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 boom. That's all okay. Then test word have results test value and require that equal values bleep test. So this would be a simple test to check the new function. I call the get bleep function, which I expect that it will return a test variable that contains the string bleep. So I get the test variable from the results and then tell the require function, which is used to check values in the test environment, that it actually is bleep. Now all I need to do is build the smart contract. So let's do that. Need to have my terminal window. Rust build test bottom lib. It's complaining about unused variables, but that is not a problem. Now, if I run my test bleed function, it should in the run window come up. Oh, it fails. I must have made an error. It's not equal. Not bleep, it's actually an empty string. Ah, isn't that interesting? What happened here? This is the moment where you start debugging. This is a standard demonstration effect.
Oh, yeah.
Par
for the course.
Oh, yeah, of course. I'm a funny guy. I added it to the Go and then I compiled the Rust. So, well, that's just, where's my Rust? Just bottom lib Rust. Oh, look what I have here. F.result dot test dot set underscore value leap an exclamation mark. Boom. And now if I go back to my terminal window and tell it to build, hope I didn't make any errors. Okay, that looks okay. And then when I go back to running the function, so the test bleep function in the run window, now it's running. Hey, my test passed. Ta-da!
There you go.
So this is how you have a quick iterative cycle. You add a function, you do your tests, or you add something to your function and you add more tests. And that iterative process makes it a lot of fun and quickly to do all kinds of interaction with your smart contract. So, yeah.
That is excellent. That's a good overview. It's amazing how much you've done, considering you've been refactoring and you've redone things probably twice now.
You don't want to know the amount of refactoring I have already done.
Yeah.
I like I said, I had a number of things that were in my head that needed to change, in my opinion. Progress of insight, like I said, a lot of CRUD in the code. So I'm literally stripping out entire areas. For example, this area, this part, these files are going to completely disappear. They're no longer going to be part of the code because that is working on the node side, and I don't want it on the node side. I want the node to be running stateless. So everything that gives the node state is going to be removed, and that's this part. That's essentially the interface, the proxy interface to the data on the node. And I'm simplifying that so that a number of data will reside on the WASM side instead. And only if you actually need state information from the smart contract state is when it will actually ask that from the node. And otherwise, everything runs in the WASM side of the smart contract, which should all be more efficient. The only drawback is that I have to create the new code 3 times because it needs to run in TypeScript, in Rust, and in Go.
Right.
So, but once I have the Go, then creating the other ones is, peanuts because you already know how to do it. It's just translating.
All right. Well, smashing job as always. I appreciate you doing that. I got a little message. I would like to, Philo wants to give us a couple words on where the voting process is. So if you guys give us a couple of minutes here, Philo, are you ready to kind of talk a little bit about voting?
As always, of course.
Thank you, Eric.
I wanna, if somebody has some questions for Eric, go for it now. I think, as always, Eric, it looks like you have real fun with this stuff, and it's even for us that are kind of outside of the coding menace. It's always pretty amazing to see how this stuff works, and it gives good insights. What's happening inside your head and inside the code, yeah.
Yeah, fun is my middle name. if it wasn't for the fun, I wouldn't be doing this.
Absolutely, yes.
Yeah, anybody got any questions? Because, like I said, I should have asked that before, but I wanted to squeeze in Philo because I know it's getting a little bit late. But feel free to pipe in if you want to ask Eric any questions. All right.
So from my side, I would like to shortly give a few updates on 3 different things. First, our vote for the Treasury is getting closer and closer. We don't give ETAs, but in the next, I don't know how to call it, in the next couple of weeks, we will be ready, actually. And so everybody that is kind of involved until now or not yet involved into the governance project, you should and you could start to think about what will happen after the vote in, let's say, implementing that it goes in favor of a community-governed treasury. There will be a lot of decisions to take, and there will be a lot of things to create and implement by the community. So I really would ask anyone that wants to be part of it to hop into the governance channels in Discord and start to take part in the discussions there and propose ideas, because actually once we have a vote, we of course want to move as quick as possible to let's say get some money out into the builders community to kickstart the development, because this will all go on together and hopefully align very well with the release of Shimmer, with the release of tokenization and smart contracts on the mainnet. So there will be a million great opportunities for projects and builders to really build apps and increase the usage and actually the real active usage of the protocol. Immense. And Treasury would be just an amazing thing to have available to support them in their effort. So that's the one thing. Other thing is, maybe a few of you have been part of the DAO Pioneers group, and we have just two days ago released our, let's say, roadmap and plan for this little 100K funding of a couple of DAO projects that we hope to support over the next couple of months. So if you are thinking of creating a DAO or are part of it, just really hop into the DAO Pioneers channel, read the documents that I've posted there with the roadmap and all the things. We would hope to get submissions for, let's say, submissions for funding until end of the month. So because this money is already available, it can be spent tomorrow, let's say it like this. And so whoever wants to be part of this little research project in figuring out how to build DAOs, how to create structures, how to create governance on this, really apply for something. We will choose 3 projects besides the 2 that we already have decided to fund, which would be the Content Creator DAO and the Moderators DAO for our Discord and Telegram moderators. But still, there are some spots open, and we invite everybody really to follow our concept and look if it would suit for you to get involved in the whole thing. Yes, bless you.
Oh, thank you.
And yeah, and one other thing which is quite new and just came up in the last, no, we are thinking about quite over a long time already, but now we finally move in this direction. Maybe some of you have heard that IOTA has a forum, a research forum, IOTA Cafe, which is, let's say, was widely used 1-2 years ago and like in 2019, but mainly by our mathematicians and researchers to really talk about core design and really develop strategies and theories how core design and IOTA 2.0 will work. But with our focus on, let's say, opening the IOTA protocol much more, involving and including the community much more in decision-making processes in IOTA, we will restructure this whole forum and open it up as a governance forum, where actually everybody is invited to go into a little bit deeper discussions about decentralization, about governance, about the whole protocol, also about the whole tech stack of the current and the future IOTAnet. So the research topics are still there and are still actively discussed there, but we also open it for the current mainnet, for Shimmer, for assembly, for smart contracts. So everything that you want to propose or that you think could be a great idea to implement will be open to discuss there. We also open this for all kind of DAOs, for the potential Treasury DAO, to have a place where we can have really focused discussions, because Discord is great, but it still is a bit complicated for following up topics over a longer time, because things get lost in chats always.
Yeah, the threads don't stay together, yeah.
Yeah. And also IOTA, the IF, the foundation, uses Slack, which is actually similar than Discord. And we have a similar thing that we kind of, especially if it goes into deeper and longer technical discussions in Slack channels, also things get lost. And so we would hope to, for one, get the community more involved, but also get more of the IF members and more of the discussions that happens in the IF Slack into the open and discuss this together with the community. And so we have already created a new structure in IOTA Cafe with some simple categories. The whole thing will get a rebranding to make it look nicer, and we're also going to launch it under a new domain. But this is still in the making in the moment, but whoever wants to lurk, it's already, the change structure is already online in iota.cafe. So you are invited to give your thoughts and to use it whenever you like. It's nothing hidden and it's nothing secret, but it will undergo a couple of more changes in the next days and weeks. Just this was something I think would be great, because a lot of people always ask okay, where can we talk about, we can continuously and deeply talk about ideas and propose changes to the thing, how IOTA works. And this Discord was not really the best channel for this. So I hope we get a little bit traction into IOTA Cafe and see how it goes. Yeah, nothing is forced, but have a look there. If you like it, start using it there. And that was my 3 little points that I wanted to bring up and spread the word a little bit.
Yeah, it's great. For those who just joined us at the last minute, Philo was talking that we're progressing. We should start seeing some serious action in the next couple of weeks on the voting. We're just waiting on a couple last minute pieces. And then he was also talking about there are 5 DAOs that are going to be funded for kind of just helping launch through the Pioneers program. So whoever wants to participate, there's you go to the Pioneers group and you can learn about that program. So they'll be funding. It's kind of just a kickoff money for people to kick off their own small DAOs. So I know that there are just a handful. I just joined in. So that's what he was just kind of talking about. So I think we're probably almost 7:30. So I think we should probably wrap this up. I appreciate everyone showing up. Eric, fantastic as always. I don't know how one man creates so much code in such a short time. You're a machine. But it is impressive every time I see it because there's so much done in between every time I see it. So thank you, everyone. And thanks, Dave, for helping me record this as usual. And we will put this up on YouTube in the next 24 hours or so. And I thank you, and we'll see you in a couple weeks.
Yes,
Talk to you later.
Thanks a lot. Bye-bye.
Okay, bye-bye.